Okay, in this video, it's section 411. We skip a couple sections. It's just from the book that we got it from. But the section is on inequalities. Make sure you do the homework. They're on the separate sheets. But it's called inequalities, which is different than an equation. So you see it comes from the same word, equalities and equation. An equation has just the equal sign. Only an equal sign. An inequality will have a less than, greater than, less than an equal, or greater than or equal sign. It holds the same properties as an equation, though. So we use the same ideas that we developed with an equation as with an inequality. Now let me show you something, and then I'll explain this in a minute, but just here on the side. We have an equality. So an inequality, instead of saying 2 equals 2, right? So that's an equation. An equality is this, where I say 2 is less than 5, which is true. So am I allowed to add 3 to both sides? Yeah, so I can go 2, and then like an equation, whatever you do to one side, I can do to the other. So if I add 3 to both sides, like that, that would get me 2 plus 3, so 5, which is still less than 5 plus 3, which is 8. So that holds true. So for an inequality, you can add something to both sides. If I did this again and I said, okay, I have 2 is less than 5, and what if I subtracted 7 from both sides? Let's do that. So let's subtract 7 from both sides, like that. Whatever you do to one side, you do to the other, just like an equation. 2 minus 7 is negative 5, and is that less than 5 minus 7, which is negative 2? Is negative 5 less than negative 2? And when you think of the number line, right, you've got negative 5, negative 4, negative 3, negative 2. Yes, negative 5 is less than negative 2, so this is still true, as it was in the beginning. 2 is less than 5. So you can see, so an inequality works the same way like an equation. So what if I did this again? So if I did this, am I allowed to multiply both sides by 3? So maybe by any number. So if I multiply both sides, 2 times 3 is 6, and that's less than 5 times 3, which is 15. Is that still true? Is 6 less than 15? Yes. So when you have an inequality, it stays true if you add, subtract, or multiply. Can I divide? So say I had 2 is less than, let's do 20 is less than 50. Is that true? 20 is less than 50, yes. Am I allowed to divide both sides by the same number? Yes, I can, like an equation. So that would be 2 is less than 5, still true. So an inequality works just like an equation. Whatever you do to one side, you do to the other. But, there is one big but. So if I have an inequality and I say 2 is less than 5, okay? What happens if I divided both sides by negative 1, a negative number? It can be any negative number. That switches this sign to be negative 2, and it switches this 5 to be negative 5. And is this still true? Is negative 2, when you think of a number line, negative 2, negative 3, negative 4, negative 5, negative 6. Is negative 2 less than negative 5? There's negative 2 and there's negative 5. No, it's now reversed. It's reversed it because on a number line, when you change from a positive to a negative, the bigger number divided by negative now is to the left of the number line, right? It switches things around. Okay, what does that mean? That means that if I was to give you, on a number line, if I was to give you, say, 3, if I divided that by negative 1 and I flipped it over to negative 3, instead of being a positive number, it's now a negative number. So on a number line, it's now flipped over. So dividing by a negative actually switches the side of the number line it's on. If I started with a negative 3 and I divide by negative 1, it would flip it over here. So whenever you divide by a negative number, or if you multiply, so it works the same way if I multiply this one by a negative 1, it flips it over. So then negative 3 now becomes a positive 3, and positive 3 becomes a negative 3. So when you're flipping sides of a number line, when you divide by a negative number or multiply by a negative number, you're switching the side of the number line. So then your greater than will now become less than, or your greater than or equal becomes less than or equal. And that happens only when you divide or multiply by a negative number. Normally it's always divide by a negative number, and it's usually the last step when we're solving. So one more time. If I have negative 4, which is less than 8, that's a true statement. I can multiply both sides by any number I want, 2, 5, 5 million. Look, negative 2 times negative 4 gets me negative 8, which is still less than 16. That's still true, right? So still true. Negative 8 is less than 16. I'm allowed to divide both sides by the same number. So negative 4 divided by 2 would be negative 2, less than 8 divided by 2, 4. Still true. But, oh, look, I can add to both sides. So negative 4 plus 3 is negative 1. That's still less than 11, so still true. But, here's the big capital B-U-T, but. When both sides of an inequality are multiplied or divided by a negative number, then this inequality sign, this one, the one in the middle, must be reversed. Reversed means switched, so instead of being less than facing this way, it would face the mouth open this way, it would face this way. Okay? This one here, it's facing this way, so it would face that way. So switch these sides. So here, I have negative 4, which is less than 8, but when I multiply both sides by negative 1, it flips this one to be the positive side of the number line. And this one here, this one flips to be the negative side of the number line. So now 4 is no longer less than 8. It's going to switch over and become greater than. So 4 is now greater than negative 8. Okay, one more time. If I had negative 4, look at the top. Negative 4 is less than 8. That's true. Negative 4 is less than 8. Right? Think of the number line. Negative 4 is less than 8. If I divided both sides by negative 2, that switches this to be positive 2. 8 goes 8 divided by negative 2, which is now negative 4. That flipped the side of the number line, so now instead of this being less, you have to switch it around so it's greater than, like that. So the sign changed. See the mouth opening this way is now the mouth opening this way. This one here, the mouth opening this way, flips the mouth opening this way. So the direction of that changes whenever we multiply or divide by a negative. Usually it's divide. Usually it's the last step when we're solving, but you kind of have to know that's the property. Okay, so let's practice now number lines. So here, so we're going to come back to that. We're going to solve, and I'll come back to that, and we'll use that in a bit. Now what I want you to do is I want you to understand what a number line is. So we know what a number line is. It goes from the negatives to the positives, right? Here, if I said that W was less than or equal, so this symbol here means when I read from the W, less than or equal. That's what I'm thinking in my brain. So what I want to do is I'm going to draw on a number line that I need it to be equal to 5. Okay, and I want you to label it. You have to label the number. If you don't label the number, oh boy, I don't even know what number you're talking about. That could be any number. So you have to label the number. Okay, so make sure you label. The check mark is me telling you to make sure you do that. So the 5 is there, and then see how it's closed towards the W? So the way I read it is W is less than, because it's closed, or equal to 5. So less than means that we're going to head to the left. So we're going to go like this, to the left. Less than, so if it's closed towards the W, that means less than. So I'm drawing a line. I kind of draw it a little above, and then that way I can show it to the side. And I need you to use a ruler, okay? And I need you to label the point. Okay, if you don't label the point and don't use a ruler, you will lose marks. Okay, because it's not good form, not good communication. Okay, so you have to tell me the number. So look, this equal makes this part here, so in your brain you're thinking solid dot. Okay, and again, we're going to be using this concept forever now, right? I use this in all sorts of grades. Okay, so I need that to be a solid dot on the 5 because it's equal to the 5, and then less than, see how it's closed beside the W. So W is less than or equal to 5, so to the left of 5. Okay, so make sure you use the ruler and label the points. The stuff on the bubbles are just me reminding you of things. Try it again. So in contrast, look, see how the mouth is open towards the X? So X is greater than, so the way I read this is greater than -3. Greater than -3 doesn't say anything about equal. So it's only open, but there's no extra line. The extra line means equal. Without the extra line, it just means greater. So how do I indicate that? So I still go, okay, it's at -3, but to show that it's greater but not equal, you do open circle. So I need to be able to distinguish it's open. Like that has to be clear. Okay, it's not about neatness, it's about clarity. Like I just need to know that that's open, so make sure it's clearly open. And then you're going to label it -3 so I know what number it is. And I want greater. So see how the mouth is open to the variable, the X? So that means it's heading to the right. Do a ruler and then show me an arrow. So it keeps going to the right. Okay, so if there's an extra line, it means also equal, so it'll be solid dot. And then this here, greater than -3, but open. So open dot. Okay, so here, if there's an extra line, it means equal, so solid dot. If there's no extra line, it's open. It's not equal to it, so it's open dot. Okay, so solid versus open. Okay, let's try another one. Here, read it from the X. X, and see how the mouth is open to the X? X is greater than 7. There's no equal, so it's going to be open dot 7, not equal. This one's equal. See, that's equal, that'll be solid dot. Open dot, solid dot. So one more time. If there's an extra line under, solid dot, no extra line, open dot, no extra line, open dot, extra line, equal to, so solid dot. So this would be a solid dot at -2. Okay, see how the mouth is open to the X, right? It's eating the X, so X is greater than 7. Greater is to the right. Greater than 7 with a ruler. You have to bring your own ruler, right, to your homework and to class and evaluation, so bring that, okay? M is less than or equal solid dot. And see how it's closed to the M. So M is closed, right? So it's closed at the beside the M. Closed, so it's less than. So less than. So you're going to do this. Draw that arrow. Okay, this one here, see there's an extra line, so equal to, so solid at 6/7. So make sure you label the point. I need to see how I'm labeling them all with a number. If you don't label the number, I don't know what number it is. And then you might say, well, it's the only number that's there. Well, I'm trying to get you prepped for future grades. And in future grades, we will actually have multiple dots. So we'll have more than one. Okay, so you do have to get in the habit of labeling it. So again, that's equal, so solid. Not equal, so open. You can put it anywhere, open. And that's -11/5. Open, double line equal to solid, extra equal solid, open, open, solid. Okay, sorry, move that up. Okay, and then over here, so we got, this is, look, the mouth is open to the X, so X is greater than, I always read it from the variable, X is greater than or equal to 6/7. Greater means to the right. Okay, here, see how it's closed to the W? W is less than -11/5. So less than, I'm doing this way. Okay,